Pluto, a distant and enigmatic celestial body, was once part of our solar system's planetary family. However, recent alarming statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have thrust Pluto back into public attention. They have made a startling revelation. Pluto might be on a potential collision course with Neptune. But how could such an event happen, and what would the consequences be? Is this a rare cosmic anomaly, or is there something more to this imminent cosmic impact? Join us as we explore the possibilities of a potential Pluto-Neptune collision. Pluto, once classified as a planet but later redefined as a dwarf planet due to its peculiar orbit, continues to captivate the scientific community. According to recent research by leading scientists, Pluto's trajectory is dangerously close to Neptune's orbit. Renowned astrophysicists like Tyson and Kaku are raising alarms about the potential for a catastrophic collision between these two planets, a scenario that could pose a significant threat to Earth. But how could such an event come to pass? Unlike any other planet in our solar system, Pluto's journey around the Sun is highly unusual. It takes a remarkable 248 years to complete just one orbit. Since its discovery in 1930, Pluto hasn't even finished one full orbit, which adds to its mystique. But Pluto's orbit is not just slow. It's also highly elliptical, vastly different from the more circular orbits of the larger planets. To complicate things further, Pluto's orbit is tilted at an angle of 17 degrees to the plane of the solar system. This inclination makes its path much more extreme than the other planets, adding layers of complexity to its movement. One of the most intriguing aspects of Pluto's orbit is its interaction with Neptune's orbit. For roughly 20 years of each orbit, Pluto comes closer to the Sun than Neptune does, defying what we might expect based on the relative positions of planets in our solar system. This naturally raises the question, why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other celestial bodies, especially the large planets. The study of Pluto's orbit began shortly after its discovery. Early astronomers were puzzled by its strange path. Unlike other planets, whose orbits are somewhat aligned with the ecliptic plane, Pluto's orbit stood out due to its steep tilt and elliptical nature. The realization that Pluto's orbit crosses Neptune's was a major point of scientific curiosity. Despite these irregularities, the stability of Pluto's orbit is a remarkable feature of space mechanics. The phenomenon known as the three-body problem comes into play when studying the movements of Pluto, Neptune, and the Sun. This problem involves understanding the way three celestial objects move and affect each other through gravitational forces. Predicting their paths is a complex task, and this is where terms like AIML libration, scope libration, and VZK wobbling become relevant. The concept of AIML libration refers to the fact that when Pluto crosses Neptune's orbit, it remains at least 90 degrees away from Neptune, ensuring their paths do not intersect. Scope libration describes the vertical movement of a celestial body in its orbit. For Pluto, this means that when it gets closest to Neptune or any other large planet, it is positioned above the plane of their orbits, offering extra protection from potential collisions. Another crucial factor is the VZK wobbling, named after the researchers VZ and K, who studied how space objects interact through gravitational forces. This phenomenon explains how Pluto, Neptune, and the Sun's gravitational pulls influence each other, keeping Pluto's path stable despite its apparent erratic behavior. Even though Pluto's orbit may seem unpredictable, this wobbling mechanism helps maintain its steady motion over long time scales. These complex forces help ensure Pluto's orbit remains stable, preventing it from crashing into Neptune or deviating wildly. The three-body problem is essential for understanding how orbits change due to the gravitational influence of multiple objects. Studying this helps us gain a deeper understanding of Pluto, our solar system, and even distant celestial bodies and their stars. Mathematical simulations conducted in the late 1980s revealed that although Pluto's orbit has these stabilizing factors, it is still chaotic. Small changes in its starting conditions could lead to significant variations over millions of years. Despite this inherent chaos, Pluto's orbit remains stable over incredibly long time scales, effectively keeping any potential disruption in check. Recent computer models have provided new insights into how the gravitational influences of giant planets like Neptune, Jupiter, and Saturn affect Pluto's orbit. These models show that Pluto's relationship with Neptune is unique. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This relationship helps to stabilize Pluto's orbit, but Neptune is not the only force at work. Jupiter's gravity plays a key role, as does Saturn's, providing additional stability. These simulations demonstrate that Jupiter's gravitational pull alone is strong enough to ensure Pluto remains in a stable orbit for billions of years. Together, Neptune, Jupiter, and Saturn work in tandem to keep Pluto safely on its course, avoiding any catastrophic collisions or other disruptions. These gravitational forces are essential for maintaining order in the solar system, and without them, the system would be much more chaotic, with planets and dwarf planets like Pluto potentially colliding or being ejected from their orbits. Understanding Pluto's orbit is crucial to gaining a clearer picture of our solar system's dynamic nature. Pluto's case serves as a prime example of how even the most seemingly unstable orbits can achieve stability through the intricate interplay of gravitational forces. It also underscores the importance of continuous observation and exploration to better understand our place in the universe. The study of Pluto and its orbit illustrates the unpredictable nature of celestial mechanics. The concept of orbital chaos, which refers to the extreme sensitivity of a body's orbit to its initial conditions, is clearly visible in Pluto's case. Even the smallest change in Pluto's position or speed could significantly alter its orbit over time. Simulations have played a pivotal role in helping researchers understand Pluto's motion. These computer models use complex mathematics to simulate how Pluto and other celestial bodies interact gravitationally. By tweaking small variables, astronomers can see how tiny changes can drastically alter Pluto's long-term orbit. In the late 1980s, these simulations revealed something fascinating about Pluto's orbit. While it may be stabilized by factors like IML and scope libration, it can still be erratic. Even slight differences in Pluto's initial position or velocity can lead to dramatic changes in its orbit over long periods. Despite the apparent chaos, Pluto's orbit remains relatively stable, enduring for billions of years. This demonstrates that while its path may seem chaotic, there is an underlying order to it. Predicting celestial events, especially those involving chaotic orbits like Pluto's, is a formidable challenge. The unpredictable nature of these systems means that long-term predictions are fraught with uncertainties. While simulations are invaluable tools for understanding and forecasting the movement of celestial bodies, they also highlight the limitations of our predictive capabilities. Any slight error in initial conditions can lead to drastically different outcomes, making precise predictions nearly impossible. The chaotic nature of Pluto's orbit serves as a reminder of the constantly evolving and dynamic universe we live in. Even as we make great strides in space exploration and understanding the cosmos, Pluto's orbit reminds us of how much is still unknown. Understanding the gravitational interactions of giant planets on Pluto provides important insights into the broader dynamics of the solar system. It reveals how the positioning of each planet can have far-reaching effects, influencing the stability and trajectory of other bodies within the system. So why are astrophysicists raising concerns about a possible collision between Pluto and Neptune now, after all these years? Neil deGrasse Tyson, a leading astrophysicist and an influential figure in popularizing the study of cosmology, provides an insightful perspective. Tyson, known for advocating the reclassification of Pluto as a dwarf planet, believes that this shift reflects our ever-growing understanding of the solar system. He does not view Pluto's reclassification as a demotion, but rather as an evolution in our knowledge of the numerous bodies orbiting our Sun. Tyson's approach to celestial mechanics is rooted in continuous learning. He sees Pluto's erratic orbit as a sign of how much more there is to discover in space. The fascination with unknowns, such as the potential for catastrophic events between Pluto and Neptune, continues to captivate scientists and the general public alike. Tyson's predictions about Pluto's future take into account its highly irregular orbit, acknowledging that anything from a close flyby to a catastrophic collision remains within the realm of possibility. Michio Kaku, another renowned physicist, joins the chorus of experts raising concerns about Pluto's long-term future. Kaku, known for his work in theoretical physics, delves into the mathematics behind the potential interactions between Pluto and Neptune. His theories suggest that while Pluto's orbit appears stable today, its future remains uncertain. He warns that over time, even minor shifts in the gravitational forces between Pluto, Neptune, and other planets could lead to a catastrophic event. Kaku's predictions underscore the vulnerability of Pluto's orbit despite its current stability. As we continue to probe the cosmic mechanisms at play, it's essential to consider the future of Pluto's orbit. Although current models suggest that a collision with Neptune is unlikely in the near future, the unpredictable nature of celestial dynamics means that we can never fully rule out such a possibility. Gravitational interactions with other celestial bodies will continue to shape Pluto's trajectory, and even the gradual transformation of the Sun into a red giant and its eventual collapse into a white dwarf could alter the gravitational landscape of the solar system, potentially affecting Pluto's orbit. While the likelihood of Pluto colliding with Neptune anytime soon seems remote, the inherent uncertainty in predicting celestial dynamics over such vast time scales means that anything is possible. The forces at play in orbital mechanics are powerful and intricate, and even the slightest change can accumulate over billions of years, potentially leading to major shifts in the orbits of distant objects. This uncertainty in space exploration brings us back to a core principle. The more we learn about the universe, the more we realize how much remains unknown. The study of Pluto and other distant objects in our solar system continues to challenge our understanding of planetary orbits, gravitational interactions, and the fundamental laws that govern the cosmos. As scientists continue to observe Pluto and Neptune, new data may either reinforce or challenge our current theories. While the idea of a catastrophic encounter between Pluto and Neptune might seem far-fetched, it serves as a reminder of the mysteries that space still holds. As our tools for space exploration advance, providing us with more accurate ways to simulate, predict, and observe these cosmic phenomena, the potential for a collision or near miss between Pluto and Neptune remains a compelling example of the complexity and unpredictability of our solar system. Whether such an event will ever take place is unknown, but it highlights the ever-changing nature of our cosmic environment. The story of Pluto's orbit invites us to think beyond what we currently know and to embrace the mystery of space. It challenges us to look at the universe with fresh perspectives and to remain open to the surprises that lie ahead. As scientists continue to unravel the mysteries of the cosmos, we are reminded that we have only scratched the surface of what the universe has in store. Whether Pluto and Neptune will continue to orbit safely or one day experience a cosmic collision remains an open question, one that only time and further discoveries will answer. As we move forward in our understanding of the cosmos, the story of Pluto's orbit serves as a symbol of the mysteries that continue to perplex and excite scientists. The potential for a collision or nearness between Pluto and Neptune, though unlikely in the near future, is a reminder of how much we still have to learn about the vastness of space. These celestial events, no matter how improbable they may seem, invite us to keep questioning the workings of the universe and the fundamental forces at play in the ever-expanding field of astrophysics. there is always more to discover. As we delve deeper into space exploration, the tools and methods used to study distant worlds like Pluto are improving. Advanced telescopes, space missions, and more sophisticated computer simulations allow researchers to track these celestial bodies with unprecedented accuracy. These innovations provide new insights into the mechanics of planetary motion, gravitational interactions, and the long-term stability of our solar system. One of the most exciting developments in the study of Pluto and its orbit is the continued advancement of observational technologies. New space missions are constantly being launched with the goal of exploring distant objects in the solar system. These missions, such as the New Horizons probe, have provided valuable data on Pluto and other objects in the Kuiper Belt, offering a closer look at the characteristics of these far-off worlds. With each new discovery, our understanding of these distant bodies becomes clearer, and we gain more insight into the processes that govern their movement. The fact that Pluto remains an object of intrigue and study, even after its reclassification as a dwarf planet, speaks to the ongoing fascination with this distant world. Pluto may no longer hold the title of planet in the eyes of the scientific community, but it still occupies a significant place in the public imagination. Its reclassification has sparked debates about the definition of a planet, the complexities of our solar system, and the ways in which our understanding of space is continually evolving. This ongoing exploration of Pluto's path reminds us of the fluid nature of scientific knowledge. What we understand today may change tomorrow as new data emerges and new theories are proposed. The potential for a future collision between Pluto and Neptune is a possibility that cannot be dismissed entirely, but it also reflects the broader theme of unpredictability in space.